Hi, good morning everyone. My name is Haridasa. I'm a product manager in Dell EMC Networking. And today I'll actually be taking you through a new product that we have recently launched. It's called SmartFabric Director. And it's essentially a fabric automation platform, but it's much more than that. It starts with fabric automation, but also blends into telemetry, monitoring, debugging, tighter integration with overlays and so on. So I've got a few slides that we'll go through, and we also have a live demo. The demo is actually being run out of our lab in Austin, Texas. So we have an engineer who's we're gonna tag team with respect to how we're gonna actually show the demo with this. Hopefully, I'm keeping my fingers crossed. Hopefully everything will go well, but the idea is to show you guys real life instead of me running a video or a screenshot of this, right? So we'll see how it goes. All right, so let's get into the product itself. So I'm gonna build out this slide. So what we are essentially trying to address are, if you take a look at some of the legacy hardware-defined networks, they're traditionally very slow to provision. There's inherently a lot of performance bottlenecks. There's obviously lower service velocity. It takes time to provision or create new services. And most importantly, and this is what we hear when we talk to customers, is the most common reason for an outage is usually misconfiguration. Somebody goes and sets something up wrong, and that causes outages in terms of services not being available, or the box not being in a sane state, or not being stable, and the network being down, and so on and so forth. So, consistent or error-free configuration of the boxes is one of the top priorities for any administrator. So, configuring the physical network, obviously, to the point where you can ensure that it's error-free and is actually provisioned to carry the workloads and the connectivity that the workloads need with or without an overlay network. So that's kind of what SmartFabric Director is being. That's the goal. That's how we started in being able to create this. When you look at how the networks have evolved, it started with legacy hardware-defined networks. Then the next step in the evolution was a software-defined network, which our sister company within the Dell Technologies portfolio, VMware, has pioneered the software-defined data center. Essentially, it's a combination of NSX, which has a couple of different roles. One is in terms of security through microsegmentation, but it also has the routing. It has virtualized the network routing to a large extent. And then there's vCenter, obviously, for virtualization of the workloads itself, right? So that's kind of how it got started, and then slowly the virtualization spread to the network.
You live in the Bay Area.
But essentially, it's for faster provisioning. So if you look at the value proposition of an SD-DC from VMware, it is the fact that you service velocity. It's the ability to provision services faster, easier to manage, single pane of glass, and ability to look at all your resources and troubleshoot faster and so on. And lastly, security, microsegmentation and security policies, consistent security policies across network is another value proposition. The third evolution of this is we actually came up with, so one of the things that NSX, when it runs, it basically doesn't really care what the underlay is, right? So it's sort of orthogonal, or it's independent of the underlay that it runs on. It just expects to have IP connectivity between the hosts, and then it takes care of the overlay. But there's an important step in terms of being able to provision an underlay network which is consistent and always consistent with the policies that an administrator may have in the network. That's where SmartFabric Director comes in.
That's what we're going
this makes sure that the physical underlay that's part of networking is actually consistent to what the overlay needs. So in terms of the actual interfaces, I mean, I'm sure you guys are all familiar with how NSXT works. We integrate with NSXT, and NSXT essentially requires to be able to route packets and to make sure that the MTU is consistent, right? There's a certain MTU size, and you won't believe how many times there have been trouble tickets and issues that came up because the MTU is not set in somewhere within the network. So making sure that these policies are actually set up consistently across the network is kind of what SmartFabric Director does. So it's a tight integration with VMware, both integrating with vCenter, which is what we'll see in the demo, as well as the integration with NSX. But that integration is mostly to make sure the network policy or the network, whatever is being set up in the network, is consistent with what NSXT requires, right? So let's moving on. So this is just to introduce, and I spoke to a lot of this slide already, but basically SmartFabric Director, like I said, is a fabric automation platform. The first version of it is using the physical underlay with Dell EMC switches, the power switches, running OS 10, right? One aspect that I want to clarify is SmartFabric Director was created to be open standards and using non-proprietary interfaces, both northbound and southbound. So in the southbound direction where it talks to the switches, it uses GNMI and OpenConfig. So these are data models that are published, right? Well understood data models in how you communicate. And GNMI is you guys are probably familiar with it. It's the Google Network Management Interface. This is the transport, right? This is how we transport. The actual data models are actually OpenConfig. So everything is non-proprietary way of talking to the switches. So theoretically, SmartFabric Director can talk to any NOS that's compliant with, that can respond to a GNMI request and uses the OpenConfig data models, right? So we started with that. So there's an implementation of GNMI OpenConfig within OS 10, which is our Dell OS for switching portfolio. So that's how SmartFabric Director communicates. Northbound, it exposes also a REST JSON interface. So everything that you can drive in the GUI through the product is also exposed through an API, right? So in fact, the GUI actually uses the APIs themselves. So there's no back door, so there's nothing inherently between something that the GUI can do which is not exposed. So the product is actually designed to be API driven from day one. And these APIs are actually published, right? So you can actually use your own orchestrator and drive everything in the product that you can do through a GUI. Again, the idea is to save time. If you look at a typical config for a BGP layer 3 fabric, we counted somewhere around 3,000 lines for a simple 8 or 10 node topology. You actually will, if you go through this product, you essentially have to give 4 input parameters. You need to give the ASN numbers for the leaves and spines. You need to give loopback IP, the loopback addresses you want to use for the switches, and the interlink subnets. That's it. It takes care of provisioning everything else. The idea is to make sure that less input, less error prone, and there's no misconfiguration. That's the essential goal. And once you configure, longer term, what we want the product to do is actually monitor, which is where we think we'll get into more advanced features as we go along, is correlation between the overlay and underlay and being able to do remediation, capacity planning, and so on, right? So the config is kind of a start to the product to be able to configure a fabric, but after that it goes through. Okay, so let me, I think I talked to a lot of this slide, but let me just highlight a couple of important aspects to it. We support, so this is, if you look at the product and if you go through the product, we call it intent-based provisioning. And intent, another way to look at intent is a template. So we supply templates for you to provision. It's not a generic NMS. You cannot go and fine-tune every little knob that the operating system allows. I want to change this parameter, like the AS path variable that BGP uses to select its thing. I mean, that's not the goal. The goal is more to give you specific templates or intents that you go and provision onto the network. So in that sense, we provide 3 intents in the first release. One is layer 2 fabric. The other is a layer 3 BGP fabric. And the third one is BGP fabric for NSXT. So the NSXT is essentially the same as BGP fabric, except it makes the additional checks of MTU sizes and so on within the network, right? So it works with vSphere 6.5 and higher. We already talked about that. One other aspect before I transfer, it actually does full switch lifecycle management. So it'll actually go and you'll be able to download newer images of the switches if you've got a security patch or something like that and you need to go upgrade the switches. And it takes care of, so we actually have a mechanism by which you can do the upgraded switches without having any disruption in traffic. So by default, it bifurcates the traffic. We recommend that you have 2 paths for every host through the network. So we will upgrade the sort of one half of the network, while the host uses the second path, and then we update the second path, right? So it's kind of makes it such that you do not have any loss of connectivity.
I've got a question for you on the L3 BGP leaf spine fabric. What kind of a leaf spine fabric are you guys recommending and deploying? Is that something like BGP unnumbered, where you're running separate autonomous systems, or 1AS with an IGP underneath, or something else? What does your BGP leaf-spine fabric look like?
So we have support for unnumbered. Recently, we've actually added support for unnumbered,
cool.
which is how we see this evolving going forward.
Sure, it's a lot simpler.
It's a lot simpler to do. But we do support the other models as well. Unnumbered is something that's come recently into OS 10. That's kind of where we are going with it as we move forward.
Okay.
Yeah. That's a great question. Thank you. I'm going to basically, I'm not going to talk a lot about this slide. I think this is more goes into the weeds of how the product is. But the only points I want to illustrate in this is that the product has a bunch of time series databases that it keeps. There's a time series database for the policy or the config side. There's a time series database for the telemetry information that you get, so you can always go back and look at all the data that you acquired over the last 24 hours, some period of time that you've been storing into this, and all these databases are actually backed up to another FTP site, so you can go back and look at historical data with what it is. And the third thing is all the changes to the network also logged into a time series database, so you can run a consistency check versus the original intent and what the current state of the network is, right? So you can always run a compliance report to be able to see that the network is perpetually consistent.